Welcome to episode 8 of our Design Patterns in Java series. So far we've covered several creational and structural patterns like singleton, factory, builder, adapter, and decorator. And in this episode we shift our focus to simplifying code bases. And to do that we'll explore the facade pattern. As applications grow, so do their internal subsystems. Without structure, your code can turn into a tangled web of classes that are difficult to understand or maintain. The facade pattern helps by providing a clean, unified interface to a set of interfaces in a subsystem. So what actually is it? The facade is a structural design pattern that hides the complexities of a system by providing a simplified interface. It doesn't add new functionality, instead it acts as a front door to a larger body of logic. It's commonly used to hide complicated logic behind a single entry point. It doesn't have to be an actual interface in Java. Interface is more widely understood as programming interface. This could also apply to API endpoints, classes, whatever. It could be a class that implements several classes. It could be an interface that does all of that. Just a programming interface. Reduce dependencies between subsystems and clients and make code easier to test, mock, and use. So some use cases are simplifying third-party library usage, encapsulating startup sequences or multi-step configuration, providing clear APIs for subsystems like payment, reporting, or document generation. So for our example, I've chosen a home theater system facade. Suppose you have a complex home theater setup with multiple components, a DVD player, although not widely used anymore. It is an example from a codebook that I used, a projector, a sound system, and lighting. Well, not lighting. The lights, not lighting in your house. That's not good. So starting a movie night usually means turning them all on in a specific order. And let's use a facade to make that process effortless. All right, let's dive into the code. And for that, I need to be small. So now I'm small. Okay, you guys can read all of this beautiful code. So what I've created is a couple subclasses, right? We have a DVD player with an on method and a play method. We have a lights class with a dim method that dims the lights. We have a projector that gets turned on and gets set on to a specific mode. I didn't use an enumeration because I'm very, very lazy when I'm making these, but you could just use an enumeration here, but I'm using a string. And we can use a sound system, and you have an on method and a set volume method. We're creating a facade, and the facade is the home theater facade. Basically what this does is we want to just be very nice to the person that's going to use our code. And all of this stuff like lights.dim, projector.on, projector.set mode to widescreen, turn the volume to 8, put on the DVD player, play the movie. We don't want the user to experience all of that. So what we've created is a beautiful home theater facade. And what you put in is all of the instances that we need. This can be done with dependency injection, of course, but for the sake of this example, it's very simple, just through the constructor, which is also dependency injection, but that's a whole nother topic. And we're not going to talk about that right now. So we have all the instances of what we need with a DVD, player, projector, sound, lights, etc. And we've created a beautiful method that simplifies all of that stuff for us. And you have to put in the movie that you want to watch. And then it goes through this whole sequence to start doing what you want it to do. And in essence, that is all that a facade is. You could make whole systems out of this with a single entry point that does a lot behind the scenes, which your user doesn't have to do. So all of those subsystems are combined into a single entry point, like I explained before. As you can see right here, we just have watch movie, which does all of these, 9 lines of code, all for you. And now in our main method, we just have to instantiate all of the stuff that we need to use. And remember, in something like Spring Boot, this can be automatically done with a dependency injection library. Then you just create your home theater facade. You put everything in and you just watch the movie, and then you have your beautiful movie night watching The Matrix without all the hassle of doing all of the other stuff. And when we run this, of course, it immediately works. We have done the whole sequence of starting our movie night, and we just have to get the popcorn right there, and we can just chill, get a nice soda, and watch your movie all night. So in essence, that's what it is. The client doesn't need to know how to turn everything on, it just calls one method and lets the facade handle the details. So the benefits of the facade pattern are simplifying complex subsystems, it reduces code duplication by centralizing logic, shields clients from changes in subsystem details, and it makes code more approachable for newcomers. There are some limitations. It can become a God object if overloaded with logic, so be sure to watch out to do that. It hides power user functionality unless carefully exposed, and it doesn't reduce underlying complexity, it just manages it better. There are also some best practices. Keep the facades thin and focused, one facade per domain or use case. Prefer composition over inheritance in the subsystem. Expose only what is necessary, avoid making every subsystem method public, and let the facade act as an API boundary between client and internal logic. This also applies to your RESTful API or anything else. Let the facade act as a boundary. So to recap, today we used the facade pattern to simplify a complex home theater system. Instead of managing each device manually, the facade lets us start a movie with a single method call. The pattern helps isolate complexity, reduce coupling, and create clean entry points into subsystems. It's perfect for APIs, utility wrappers, and managing workflows that involve many steps. In the next episode, we'll look at the observer pattern, where objects can subscribe and react to changes in other objects, the foundation of event-driven programming. Thanks for watching, and as always, like, share, and subscribe for more episodes. Have a great day and happy programming. See you next time.